Welcome to our presentation on the work that we have been doing at the Levicki Lab.
Our lab is located on the 8th floor in room 820. This is our spectrophotometer, where we do our preliminary analysis. And this is our whispering gallery mode, or WGM for short.
The work that we are conducting pertains to colloidal aggregation of small molecules like curcumin, silibolin, and nicardipine. These compounds could have useful properties in medicine, but they have trouble dissolving in water, which is an important facet needed to be a therapeutic.
We store our compounds in DMSO, an organic liquid that dissolves these molecules. Here's curcumin in 4 vials, each having half the concentration of the last.
We also have a buffer at a pH of 7, which is similar to the regular water you get from your tap. This helps us to make sure that the molecules don't react when we're testing them.
When we are ready to test our compounds, we add 30 microliters of our compound, 1,470 microliters of our buffer, and 1,500 microliters of deionized water. This means that we have 1% of the mixture as DMSO, which allows the compound to start mixing in what is primarily water.
We run a spectrum of different wavelengths looking at the peak absorbance, showing us what light our compound blocks out.
Each time we run, we see that the absorbance decreases. This is because our compounds prefer to stick together rather than dissolve in the water.
These are a couple of the data that we have collected. Some mixtures drop in concentration quickly, while others take a bit longer.
The property we are observing is important because it allows us to understand how quickly the compounds form structures, called aggregates. The more aggregates, the lower the concentration we observe, due to the fact that they are leaving the solution.
This is when we bring up our other machine, the WGM.
The WGM can have a protein of interest attached to it, and we can pass small molecules through looking for a match to bind.
If there is a match, the WGM shows a new signal, and we note that the molecule could be a new medicine to use.
The issue, however, is that a big aggregate could not non-specifically bind, causing a false signal to be shown.
Usually, scientists would have to run the experiment again, with an aggregate preventing detergent to stop the false signals.
But with our work, we are trying to make the WGM detect flyby events or from direct attachment of the aggregates to the sensor, which it couldn't do before.